Hello everyone, welcome to this video. In this video we are going to solve another question. So let's have a look at the question. They are saying in the dihedral group Dn, explain geometrically why a reflection means we are taking a reflection about some line, right? For example, in a mirror, followed by a reflection must be a rotation. So we already know the group operations of dihedral groups. The elements, they are rotations as well as reflections. So for showing for dn, it would be quite difficult until we do it theoretically, right? So in order to show it geometrically, I am taking the case of d3. Right, so for d3 we know this is the symmetries of an equilateral triangle, right? So I am taking all the cases of this d3 in order to show you the exhaustive cases, all the cases which involves this thing, right? So for all the cases, this result in d3 would be true. A reflection followed by a reflection, it must be a rotation. Let's see how. Okay, so in the first case, when same reflection is applied after the initial reflection, suppose we are taking the reflection L1. What is L1? L1 is the reflection through the vertex A, which passes through the center and it crosses the midpoint of the opposite side, right? So this is the initial line by which we are taking the reflection. So C would go to the position of B and B would go to the position of C, right? So this A would be kept fixed. However, B and C would interchange their positions, right? Again, we are applying the same reflection over here. So if we apply the same reflection, what we are doing? We are keeping this A as fixed and we are just interchanging this B and C, so that we would have C here and B here. Now notice that this is the same as this initial a triangular position, right? So that means we are saying we are rotating that given triangle by 0 degree, or we are not doing anything to it. So this is a rotation, right, by 0 degree. So that means a reflection followed by a reflection is a rotation. Similarly, when you see we apply L2 reflection after L2, what do we have? L2 is taking the line through the vertex B and making it pass through the opposite side, right? So here you see B would be kept fixed, however C and A would interchange their positions as before. Again we are applying L2 reflection onto it, so B would be kept fixed, so A and C would interchange their positions, so we have C here and A here. So you notice that this thing is exactly same as this position of the triangle. So that means while moving from here to here, we are applying R0 transformation to it, which is a rotation. So reflection after reflection gives us rotation in this case. For the next case, in the next case we are applying L3 onto it. L3 is taking a line through the point vertex C and passing it through the opposite midpoint of the opposite side. So C would be kept fixed, however A and B would interchange their positions. Similarly, again we are applying L3 onto this transformed triangle, so C would be kept fixed, A and B would interchange their positions, right? So you see this triangle and this triangle is the same. So that means from moving from this triangle to this triangle, we are applying R0 transformation. So whenever we apply the same reflection onto the same reflection, we would have a rotation, right? This is first case. Now what if we apply another reflection in the first part and another reflection in the second part? Do we again get a rotation? Let's see it in the case of D3. Right, so we will discuss all the cases of D3. So suppose we have this initial equilateral triangle. So initially we are applying L3 onto it. One time we are applying L1 thereafter, and one time we are applying L2 thereafter. So let's see in both the cases what do we have. For the first case here, first of all, when we apply L3 onto it, we are taking reflection about this line. So C would be kept fixed, A and B would interchange. So we have this triangle. Now on this triangle, we are applying L1. L1 is taking the reflection through this vertical line, right? So here B would be kept fixed, A and C would interchange their positions. Now look at the transformation in moving from this triangle to this triangle. So what has happened? A has gone to the position of C, right? So A has moved here, C has moved here, B has moved here. So that means we have an overall rotation of 120 degree, right? So this reflection followed by this reflection gives us a rotation by R120. This is in the first case. What about the second case? In the second case, we are having this triangle, we are applying L3 onto it, we are getting the same elements. Now here we have to apply the reflection L2. When we apply the reflection L2, we have a line which passes through the vertex A, and it is going like this. So I hope you must be clear with these reflections. If not, you can go back to question number 1 in this playlist and you will be getting to know all the details. Correct? Now here A would be kept fixed because we are taking a reflection. B and C would interchange their position. So when you move from this triangle to this triangle, what is happening here? This A is moving to this position, this C is moving to this position, and B is moving to this position. So that means overall we are rotating the triangle by 240 degree. So in moving from here to here, we have a rotation by 240 degree. So here also the result is rotation when we apply reflection after reflection, right? Similarly, in the case when we first apply L2 and then apply L1 or we apply L3, in this case we are also getting rotations, right, of 240 degree and 120 degree. In a similar way, if you first apply L1 reflection and then first of all you apply L2 or you apply L3, in both the cases the final result that we are getting is a rotation from the initial position. Initial position was this one, so we are getting a rotation first of all by 120 degree and then by 240 degree, right? So in all the cases, we saw all the cases where reflection after reflection gives us rotation. This fact is also verified when we see the Cayley table for D3. So when we see the Cayley table for D3, in this case you see when we these are our reflections, correct, and these are our reflections. So when we apply reflection after reflection, we would have this as a resultant, and you see all of them, they are nothing but the rotation. So therefore our this is what we wanted to prove here in this case. And in fact, for every Cayley table for Dn, you can notice this thing that reflections after reflections would definitely give you rotation. So this is it for this question. Well, that is it. Thank you for watching.